Today's our topic from determinant class 12th, and now today we discuss there are two topics in this video. One is adjoint of matrix and other is inverse of matrix. So first in previous video I so many types of questions we did there, like evaluation of determinant and area of triangle and so many properties related to the determinants we did it. But now there are two topics remaining from the determinant. So now we start. There are two topics today we discuss, like adjoint of matrix and inverse of matrix. So first here we start adjoint of matrix. So what do you mean by adjoint of matrix? Here first we define the concept of definition. First we define here, like what do you mean by the adjoint, and here definition is the adjoint of square matrix Aij, the element, and order is n by n, because here we discuss like square matrix. Square matrix, it means number of rows and number of columns are same, is defined as the transpose of matrix Cij, and here Cij it means cofactor. So directly we say that it is denoted by small adj like here, and then so on. So overall, if we summarize whole definition in form of like this only, because you find out any square matrix they are adjoint, then this is the simple definition of adjoint. Adjoint of A is matrix inside cofactors, and you taking transpose of all cofactors, that is your adjoint of matrix. So you don't learn this type of definition only, you revise in your mind, you keep this thing only, adjoint of A which is equal to cofactors of transpose only. This is the very small definition related to the adjoint. So now some properties they are related with the adjoint of matrix. There are 6 properties. So one by one here we discuss, like A into adjoint of A equal to adjoint A into A, which is equal to determinant of A into I. I means identity matrix. Identity matrix is their diagonal element is 1, other than diagonal elements are 0. Like it may be 2 by 2, 3 by 3, because identity matrix always a square matrix. And here we call like determinant. Determinant always we find out from the square matrix. So first property is this, and then second is, if you find out determinant of adjoint of A, which is equal to determinant of A to the power n minus 1, where n is the order of matrix. Suppose your matrix is given like 2 by 2, and then here you determinant of A into 2 minus 1, it means directly it is determinant of A, because 2 minus 1 is 1. If your order is 3, then you put 3 minus 1 here, that is 2. So your square of determinant is 2 here, like, and same. And now third property, if you have two square matrix, and you find out their product first AB, and then find their adjoint, and then you find separate adjoint of B into adjoint of A, then that is equal to this much. So this is the third property. And now fourth property is, you taking adjoint of A transpose. It means you have the matrix and you first transpose of that matrix, and then you find the adjoint, which is equal to adjoint of A and then transpose. So both the parts are same now. And then one more property, adjoint of A of whole determinant, which is equal to determinant of A to the power n minus 1 square. Now property second and fifth both are same here. Okay, but here only the case is adjoint of A only, and then whole determinant of n minus 1. But inside this here, adjoint of A, which is determinant of A into n minus 1 of whole square. And similarly again same, without you taking determinant, you write down inside value only, adjoint A, which is equal to determinant of A to the power n minus 2 into A. Okay, you find taking the examples and then prove one by one all the properties, and otherwise you check out yourself if these all properties are satisfied by us. Given some examples, you use here example, and then one by one all the properties you show out. Okay, and but before of this, these all the concept, like mainly here we discuss about the adjoint, that is a very short form, like not this type of definition you learn only you revise in your mind adjoint of A which is equal to cofactors of transpose, this much only. Okay, and now some properties that are related with the some objectives may be asked in the board examinations. And now we have an example of a matrix in which first you find adjoint, because first here we do the questions like how we find the adjoint of given matrix. So we have the example, first here we taking like 2 by 2 and then we taking the example for 3 by 3 and then so on. So here we find out, because basically our definition is what? Here we find out the cofactor of transpose. It means first we find the cofactor, because in previous video I discussed about the minus and cofactors. So cofactor also we know very well, and again here we define cofactor. It means first you find like it is denoted by Cij, and now here you find out C11, because how many element inside a matrix is given, like 4 element is given, then you find out 4 cofactors. So 4 cofactors, like the place value is important. Here C11, C12, C21 and C22. So you find out 4 cofactors. And now 1 means you leaving out first row and first column. So you leaving out first row and first column, then you have 5. And one more thing, you revise it here, because cofactors minus having no place value is important, but in cofactors place value is very important. First you add your place value. Here 1. First one shows for row and second one for column. So you adding both digit here 1 plus 1, then your sum, then your total is 2, and 2 is an even number, then there is no change in sign. If this place value sum is odd, then you put minus sign before of the answer. Okay, so C11, that is fine. And now you find out C12. C12 means first row and second column is leaving out, then minus sign is important, so you put minus 4 here. And now C21, again 2 plus 1 is 3, again odd, so you put minus sign. Now 21, second row and first column you leaving, then you have 3, so your answer is minus 3. And then C22, second row and second column, then your answer is 2. Okay, then you find out all cofactors. So now here we write down for the adjoint. What is the definition of adjoint? Again here we show out the formula. Adjoint of A is cofactors of transpose. So here we write down adjoint of A, which is C11, 12, 21, 22 of transpose. And then you put the value inside. Here C11 you have 5, C12 you have minus 4, 21 is minus 3 and 22 is 2. Okay, then of transpose. After transpose you have 5, minus 4, minus 3 and 2. Okay, so directly you have adjoint of A equal to this much. So this is the answer. So this is very easy going, because adjoint is not so typical. Only here you find out cofactors and then write down the answer only. But one thing is important, your question and answer. First you watch your question and answer, and then you find out your diagonal. Okay, 2, 5, but here your diagonal is 5, 2. Okay, and then second diagonal is 3, 4, but here you have minus 3 and minus 4. It means that is directly we observe and we find out the trick for 2 by 2. It means you have order of 2 matrix, then you write down direct answer without any finding cofactors. It is only trick wise. If you have the objective, then you write down in this way, or you check out in this way. Adjoint of A, only it means you change their diagonal element, you replace it, interchange only. Here 2, 5, here 5, 2, and this diagonal is same, only change the sign. You got the answer. Okay, so some example again here we try. Example 2, we have adjoint of A equal to, we write down here minus 3, minus 4, 0 and 5. Okay, then again we find out cofactors like C11, first row and first column we out, you have 5, C12, minus sign is important, 1 and 2, so 0 have no meaning. 2, 1, again you put the minus sign, but you have 2 and 1, then minus 4, so you put minus 4, so your answer is 4. And now here 2, 2, which is second to second column, you have minus 3. Okay, then you write down the formula for adjoint of A, which is C11, C12, C21, C22 of transpose, and then we substitute the value of adjoint of A, which is C11. We have 5, 1, 2, 0, 2, 1 is 4, 2, 2 is minus 3 of transpose. So write down the answer here, 5, 0 and 4 minus 3. Okay, so now here we observe again, we have the right diagonal. Okay, in right diagonal we have minus 3 and 5, so their elements are interchanged here, and only one thing is important, your this diagonal, they have to change their sign. It means directly you write down the answer. So you got the trick of 2 by 2 only. This trick is used for only the second order of matrix. So now here we see again more examples, like you write down directly. Suppose you have 3 examples, you have the determinant matrix like minus 6, 7, 3 and 4, and then you write down answer adjoint of A, which is only this diagonal change their element, interchange their element, so 4 here and minus 6 here, and then this diagonal have only sign change, so minus 7, minus 3 is your answer. Okay, so you add on directly, you got the trick only. You change their diagonal, right diagonal and left diagonal you consider here, right diagonal you put their interchange their digit, and left diagonal you change their sign only, and then you got the answer of adjoint of A. So that is very easy trick, you find out adjoint. But this trick is used only in case of your matrix is given in form of 2 by 2 order. Okay, not for 3 by 3. Now we see the example for 3 by 3. Okay, now we have the example 4, and now order is 3 by 3. Because previously here we have some examples, they are related with the order of 2 by 2, but now some examples they are related with the 3 by 3. So now here we try for find adjoint of order 3 by 3 matrix is given, and then you find out like same concept is here. We know the definition of adjoint of A, which is first you find the cofactor and then you taking transpose. The concept is same, formula is same, it not depend on the order. If order is different then you use the different trick, but trick and formula is again you use the same. So now here you find out like C11. C11 means you first leaving out first row and first column, so then you have like this determinant. So C11 you put in the determinant and their order is 2 by 2, so 1, 2 and 3, 1. Okay, so 1 minus 6, that is minus 5. Similarly C12, but you put minus sign because 1, 2, 1 plus 2 is 3 and 3 is an odd number, so you put minus sign before of this. So 1, 2 means first you leaving out first row and for second column. Okay, then this column you leaving out, this row you leaving out, then you have this 2, 1 and 3, 1. So you write down here 2, 1 and 3, 1. Okay, and then you simplify, minus of 2 minus 3, which is 1. Okay, then similarly now here we find out C13. 1, 3 is again even, so don't put plus or minus sign there. Now 3, first row and third column, this and this. So you have 2, 1 and 1, 2. 2, 1 and 1, 2. So now your result is 2 to the 4 minus 1, you have 3. Okay, then we have like C11, 1, 2 and 1, 3. Because there are 9 elements, so we find out 9 cofactors. Similarly, 2, 1, again we have odd numbers, so you put minus sign. And then 2 and 1, it means 3, 2, 2, 1. So you write down here 3, 2, 2, 1. So minus of 3 minus 4, your answer is again 1. And now C 2, 2. Only you write down the corner terms 1, 1, 2, 1. So you write on 1 1 and 2 1. So you have 1 minus 2. Your answer is minus 1. Similarly, C2 3. Again minus sign here. 2 3 means this and this. So 1 1 3 2. Again 1 1 3 2. So minus sign 2 minus 3. Your answer is 1. And then 3 1 positive. So without any sign you put here 3 1. 3 1 means third row and first column. So 3 1 2 3. 3 1 2 3. 3 3 are 9 minus 2. Your answer is 7. And then C3 2. So 3 plus 2 is 5. You put minus sign here. 3 2 means again you living through third row and second column. So 1 2 2 3. And then minus of 3 minus 4, you have 1. And the last is C3 3, which is positive. So 3 3 means this row and this column. So 1 2 3 1. 1 2 3 1. So you have 1 minus 6. Your answer is minus 5. Okay, then all cofactors here we find out because of C11, C12, C13 and all 9 cofactors here we find out very easy way. And one thing is, remember, again I revise it, for the place value 1 1 means you have 1 plus 1 is even, therefore here sign not including, but 1 2, that is 1 plus 2 3, 3 we have odd number, so minus sign here. So only in cofactors you remember, if your place value sum is odd, then you put minus sign. If your place value sum is even, then you don't put sign minus sign there. Okay, and then we write down the formula for adjoint. We know that formula, adjoint of A, which is C11 1 2 1 3, C21 2 2 2 3, C31 3 2 and 3 3 of transpose. Okay, and then here we substitute the value. C11 we have minus 5 and then 1 and then again 3. Okay, then 1, then minus 1, then 1, 7 and then 1 and then minus 5 of transpose. Okay, after transpose we got the value of adjoint, so minus 5. This is the first row, you write down in column. So 1 3 here. Second row is 1 minus 1 and 1. Third row, that is third column now, 7 1 minus 5. Okay, so this is the answer of adjoint of A. Okay, so this is the very easy now again, because order is 2 by 2, directly you have the trick, therefore you write down direct answer. But you have the like order of 3 by 3, in which you find 9 cofactors, you write down in a particular matrix format and then you taking the transpose, then you got the adjoint of A. So you try many more examples related to the same, because in next topic, inverse of matrix, then also we use the concept of adjoint there. So no more examples are required for the practice, because in inverse of matrix also we do the same practice, because our inverse formula they are related to the adjoints. So now we start the topic inverse of matrix. Okay, then now we have the topic inverse of matrix. Inverse of matrix, before of this here we study like adjoint, and then same concept here we use for the inverse of matrix, because here again we have the discuss about the square matrix. And square matrix here we consider A equal to Aij, their order is n by n, it means number of row and number of columns are same. And the formula for inverse is A inverse equal to 1 by determinant of n to adjoint of n, where determinant of A is not equal to 0. If determinant of A equal to 0, then inverse is not possible there, because that is not defined case. And then here we define like A inverse. Inverse, it means, suppose you consider there are two matrices of same order like A and B, and you multiply, okay, and then multiply, you have identity. Now here we have the example how we explain about the inverse of matrix. Like you consider two matrix and two matrix having same order like 2 by 2, 3 by 3, and now you multiply, you find out the product of both the matrix, and the product is identity converted into the identity matrix, and then you write down B, and this A tends to here, so A is inverse. It means B is your answer. Okay, so here the same concept you utilize here, because invertibility it means first you find out their condition, we discuss about the two matrix, and then you find out the formula. But here we write down the basic formula like A inverse equal to 1 by determinant of A into adjoint of A, and where determinant of A is not equal to 0. Okay, then some properties again they are added with the inverse, because in adjoint also we have some properties, and in inverse also we have some properties like same here, because MCQ questions having this type of property also important, because some questions they are directly given in form of the properties. So how you try like directly here which property they are related. So now first property is inverse of inverse is A. Okay, you find out any matrix of inverse, and then again find out their inverse also, then you find out itself. Okay, and then you have two matrix, okay, A and B suppose, and you find out their product inverse of matrix, then they are separately B inverse into A inverse. It means their place are changed, not A inverse into B inverse, B inverse into A inverse is there. And then we use the concept of transpose, inverse of matrix of transpose or transpose of matrix of inverse. These two cases are equal to A inverse, so there is no change. You find out directly A inverse, or otherwise you find out inverse and then you find the transpose, or you find out inverse and then transpose. So all cases are same, that is directly did with the A inverse. And now fourth property, if you find out determinant of A inverse, which is equal to nothing, only 1 by determinant of A. And then fifth property, you find out adjoint of A inverse. It means 1 by determinant of A into A. And the last property, adjoint of A inverse, which is equal to adjoint of A inverse. It means first you find the adjoint of given matrix, and then you find the inverse, which is equal to, you find out inverse and then find their adjoint. So both values are equal. You also maybe try with the help of some examples and then show out this example is true or not. So here we have the condition, first we find the adjoint. So let us try for the example. We have like try for 2 by 2. Okay, we have the example. Now you write down 1, minus 3, minus 7, minus 2. Okay, find the inverse. And then find the inverse, suppose inverse of matrix. Right? So first, what is the formula for inverse? A inverse equal to 1 by determinant of into adjoint of A. So therefore first we find the adjoint. Basically first we find the determinant. If determinant is not equal to 0, then you go further. If determinant is 0, then why not? Because determinant of A is 0, then your inverse is not possible. That is not defined case. So first here we find the determinant. So 1 minus 7 you have here, minus 3 and minus 2. So therefore minus 2 and minus 21, which is minus 23. So determinant of A is not equal to 0. So inverse is possible. And now inverse is possible, so second step is what you find out adjoint. Adjoint, for adjoint you write down adjoint of A, which is, we know that C11, C12, C21 and C22 of transpose. It means first you write down the cofactor of the given matrix. Again same concept, C11 means minus 2, C12 first row and second column element, then you have 7 because place value is important here. 2 1 second row and first column, then you have 3, 2 2 you have 1. Okay, and then transpose of this, so you write down here same minus 2 7 and 3 1. Okay, again you try the concept or trick, because this matrix is given of 2 by 2, then only your This right diagonal 1 minus 2 is here, so this is minus 2 and 1. Only change their diagonal element, you interchange, and then this diagonal having the sign change only. It means here minus 3 and minus 7, so in after adjoint they are both in plus. So you find out adjoint of A. Now you use the direct formula A inverse, which is 1 by determinant of A into adjoint of A. So very simple now, 1 by minus 23, and then adjoint is, you write down minus 2 and 7, 3 and 1. Okay, so very simple, you find out their inverse in very easy concept. Okay, you got first, how you find any value of the same concept you apply here. So now we use the property first, like A inverse of inverse is 1, A again. So now this, we have this determinant and this is the answer of A inverse. So again you find out the inverse of this, determinant of this. So you find out inverse of this, it means first you find out the like this determinant again. So determinant of A inverse you find out. So you have 1 by minus 23 is outside because it is constant of minus 2, 7 and 3, 1. So we have 1 by minus 23 and here minus 2 minus 21. So answer is 1. Okay, so determine this, have the inverse is again now the same, and then you find adjoint of A. Adjoint of this A inverse, then this is the, again you have the same concept like here you have minus 2 and 1, then you write down their values directly with the help of transpose, and then we have again this 1 1, you have 1 and then 1 2 you have minus 7 and 2 1 you have minus 3, and similarly 2 2 you have minus 2. Okay, and then transpose of this matrix. Okay, we have the same result like 1 minus 7, you put here 1 minus 7 and then minus 3 minus 2, so there is no change, and then we see that because here 1, so we have A inverse of inverse which is equal to A. So your first property is true. In the same way you try the second property, third property, fourth property, fifth property and sixth property. But here we try for only example with the help of 2 by 2, and now here we try inverse case of 3 by 3. If order of 3 by 3 is given, then how we find the inverse. Okay, then we have the example of same here like now, but we have order of 3 by 3 matrix and the concept is same, you find the inverse of this matrix. So now first we start like according to the formula, because we know first you write down the basic formula, you find the inverse, means you write down first the basic formula of inverse is 1 by determinant of A into adjoint of A. Okay, here first you show out for the determinant of A. It means first you find determinant of this matrix. You write down form of matrix determinant first, and then their element you write down as it is. So you start you from 2, like you have minus 1, 2, 0, 1. You have minus 1, then 4, minus 7, 0, 1. We have plus 3, 4, minus 7, minus 1, 2. Okay, then minus 1, minus 0, 4, minus 0, plus 3, 4 2s are 8, minus 7, then 2 into minus 1 is minus 2, minus 4, and then plus 3. Okay, so we have minus 6 plus 3, which is minus 3, and determinant of A is not equal to 0 we have. Okay, so this is the case of your determinant of value not equal to 0. So now we start for the now next going is adjoint of A, because first work is over. Your determinant value is not equal to 0, it means the inverse is possible. So now we find out for the cofactors first, because the basic concept of adjoint is what? You find out cofactors. Cofactors of the adjoint, for adjoint, because we know the definition of adjoint. Adjoint of A, which is Cij of transpose. So first here we find all cofactors from the given matrix, like C11. So you write down -1, 2, 0, 1, which is -1. Now we write down C12, we put minus sign because we know that their sum is odd. So 4 minus 7 and 0, 1 we have, so minus of 4 only here. So you got -4. Similarly, C13, 13 means first row, and first row you living and then third column is living. Then 4 minus 7 minus 1 and 2. We have 8 minus 7 is 1. Similarly, we find 2, 1. We put minus sign here. 2, 1 means second row and first column. So you have 1, 2, 3, 1. Then minus of 1 minus 6 is plus 5. And then C22. 22 means corner elements you have only. 2, minus 7, 3 and 1. And then we have 2 plus 21, which is 23. And then 2, 3. 2, 3 you put minus sign. And then minus sign you have 2, 3 means second row, third column. 2 minus 7. And then 1, 2. Okay, so you have minus of 4 plus 7, which is minus 11. Then we find 3, 1. 3, 1 you have plus sign. Definition is same. Third row and first column. So 1 minus 1, 3, 0. That is 0 plus 3. So answer is plus 3. C 3, 2. You put minus sign. 3, 2 means second, third row and second column. So 2, 4, 3, 0. 2, 4, 3, 0. Okay, so we have minus sign, then 0 minus 12, which is plus 12, and last value 3, 3. That is from the again corner side, third row and third column you ignore, then 2, 4, 1 minus 1. So minus 2 minus 4, we have minus 6. Okay, all cofactors are here we have. Then we write down for the formula of adjoint. We know that formula, adjoint of A, which is equal to C11, C12, C13, 21, 22, 23, 31, 32, 33 of transpose. And then you substitute the value of C11, you have minus 1, minus 4, and then 1, and C21 is 5, is 23, minus 11, then 3, then 12, then minus 6 of transpose. So after transpose we have minus 1, minus 4 and 1. This first row convert into the column. Second row is 5, 23, minus 11 is second column. Third row 3, 12 and minus 6 is third column. So this is the answer of adjoint of A. Okay, then now write down the final. We have formula A inverse, which is 1 by determinant of A into adjoint of A. Okay, so you write down 1 by determinant of A. 1 by determinant of A we have, that is minus 3. and then this all values you write down here, -1, -4, 1, 5, 23, -11, 3, 12, -6. So this is the answer of A inverse. Okay, that is again very easy. You find out because we know that the concept of adjoint is again we use in the inverse formula. Therefore, we try only one or two examples because all examples if you try as a self practice for the inverse of matrix. So inverse in which we use the concept of adjoint also because adjoint is a part of inverse. So basically you some questions try for the adjoint but maximum question you try for the inverse because inverse having the more properties, adjoint and inverse having 6 plus 6, total 12 properties they are related with the adjoint and inverse of matrix, and they are also very important because all MCQ depend on the properties. So first you revise the all property and you also check or verify all the property with the help of examples. You consider an example and then put in the property, both are verified or not verified, you check out. Okay, you do the self practice and try all the properties in an example. You have AP and all these things. Okay, again I summarize all topics like here in this video we discuss about the two topics. First is adjoint of matrix, second is inverse of matrix because they are related to each other. We find out adjoint, it means they are related with the minus and cofactors because in previous video I explained about the minus and cofactors. So your adjoint of matrix is basically totally depend on the cofactors. So we find all cofactors, find out cofactors, and then we taking the transpose of all cofactors of matrix, we got the answer of adjoint. Similarly, same concept we use for the inverse of matrix because only one thing is different. In inverse of matrix, we have only one different case like 1 by determinant of A into adjoint of A. It is also part of adjoint. Only one thing is different like determinant. You find out 1 by determinant of A. Only here is possible determinant A. You find out any matrix of their determinant is 0, then inverse is not possible. Only in case of determinant is not equal to 0, then you find out A inverse, and then you go the further for study like adjoint of A and then same, and then only you put it substitute in the formula. So you have the value of inverse of A. Okay, so you try some questions, they are related with the inverse of matrix and adjoint of matrix. You do the practice because now last topic is remaining of this chapter is application of determinant and matrix. Okay, some word problems they are related with the applications, maximum question, and then simultaneous equation we find out with the help of matrix method. So some questions they are related with the application is remaining only in this chapter, but now most of the chapter is completed with the help of all topic, all concept, because we categorize this topic in 8 subtopics. Okay, so determinant chapter having 8 topics are there, and then 4 videos we have, and then all topics are completed, but one topic is remaining here like applications. So in next video we'll see the concept of application of matrix in which we discuss about the word problems and the simultaneous equation.